This video presentation is concerned about cooling towers.
Our topic concerns about cooling towers. Have you ever heard about cooling towers? How does it work? What is its importance in the industries? Do you know how to calculate the different parameters involved in the cooling tower operations? Hi, this is Margaret Rose T. Recinto. Cooling tower is a heat rejection device which extract waste heat to the atmosphere by allowing the water stream to be cooled to a lower temperature. There are different variables and parameters that we may encounter in the calculations in cooling tower operations. One of the variables is the absolute humidity. This is the amount in pounds of water vapor carried by 1 pound of dry air given by this equation. H is equivalent to mW raw all over MA quantity P minus raw, where mW is the molecular weight of water, MA is the molecular weight of air, raw is the partial pressure of water vapor in atm, and P is the total pressure in atm. Another variable is the percent absolute humidity or the percentage saturation. And this is defined as the ratio of absolute humidity to saturation humidity. Next, percentage relative humidity or RH. This is defined as the partial pressure of water vapor in the air divided by the vapor pressure of water at the given temperature. Saturation humidity or HS. This expresses the pounds of water vapor carried by 1 pound of vapor-free gas when the vapor is in equilibrium with the liquid, which is considered as the condensed vapor, or the solid as ice, at the temperature and pressure of the given gas. Dew point or saturation temperature, TD. The temperature at which a given mixture of water vapor and air is saturated. For example, the temperature at which water exerts a vapor pressure equal to the partial pressure of water vapor in the given mixture. Humid heat or CS. The heat capacity of 1 pound of dry air and the moisture it contains. This is given by C sub S equivalent to 0.24 plus 0.45 H, where 0.24 and 0.45 are the heat capacities of dry air and water vapor respectively, and both are assumed to be constant. Next, humid volume or V sub H. This is the volume in cubic feet of 1 pound of dry air and the vapor it contains. Next, saturated volume or V sub S. This is the humid volume when the air is saturated. Wet bulb temperature TW. The dynamic equilibrium temperature attained by a water surface when the rate of heat transfer to the surface by convection equals the rate of mass transfer away from the surface. Dry volume. Volume in cubic feet occupied by 1 pound of the carrier gas. And the enthalpy of the gas mixture is the energy of the dry gas and its water vapor constituent. Now, let's define psychrometry and humidification. Psychrometry is concerned with the determination of the properties of gas-vapor mixtures. Air-water system is by far the most commonly encountered system in industries. This is also the systematized knowledge of the properties of air and water, but its broader meaning includes the principles which govern the properties and behavior of mixtures of the so-called fixed gas with condensable vapors. On the other hand, humidification is the evaporation of water into the air for the purpose of increasing the air humidity, and it involves simultaneous heat and mass transfers. Cooling tower, as I've said earlier, is an equipment used to cool hot cooling water from a condenser or other transfer units by bringing it into contact with unsaturated air. It is also used for the conservation of cooling water. Cooling tower types can be divided according to fan setting or by airflow direction. For fan setting, we have natural draft and mechanical draft, where mechanical draft can be further classified into induced draft or forced draft. For airflow direction, we have cross flow and counter flow. Natural draft. It utilizes buoyancy or density difference via tall chimney. Warm, moist air rises due to the dry, cooler outside air. At the same pressure, warm, moist air is less dense than drier air. In mechanical draft cooling towers, it can be further classified into forced draft and induced draft cooling towers. In the forced draft cooling tower, the fan is installed at the base of the tower. The air is forced in at the bottom and discharged at low velocity at the top. This arrangement allows easy maintenance, inspection, and repairs of the equipment. Since the fan is not subjected to hot, humid area at the top, corrosion is also avoided. One of the disadvantages of this is the excessive recirculation of the exhaust vapors back into the air intake due to the low exit air velocity. On the other hand, induced draft cooling towers is the most common type used in industries. This type of cooling tower is the opposite of mechanical draft. The fan is located at the top of the tower. This can be further classified into counterflow arrangement and cross-flow arrangement. The cross-flow tower can be made progressively longer in the direction perpendicular to the airflow and shorter in the direction of the water flow, until it loses its inherent potential difference disadvantage. The airflow is directed perpendicular the water flow. Counterflow arrangement is the most advantageous type and efficient type since the coldest water comes into contact with the coldest air, which in turn obtains the maximum enthalpy potential. The greater the cooling ranges and the more difficult the approaches, the more distinct the advantages of the counterflow type of cooling tower. For the significance of cooling towers, here is Jamaica P. Aga to discuss.
I'm Jamaica Aga, and I will be discussing the significance and applications of evaporative cooling and also the objectives of the discussion. Now, let's move on with the significance of evaporative cooling. The two major reasons for the preference of employing evaporative cooling system in process industries are the maintenance of equipment and environmental considerations. Environmental considerations includes conservation of water being used in the process industries and also the removal of process waste heat in process industries. In engineering, evaluation of the evaporative cooling process is important in order to arrive at the optimum design to which we can increase the efficiency of cooling towers. We all know that cooling tower is one of the widely used equipment in evaporative cooling system in most of the industries worldwide. Now let's go to some applications of the cooling tower in industries. The first one is the use of cooling tower in the humidity control of a room or a plant. As we all know, humidity is one important parameter of most of the manufacturing industries, like for example in food industries. That's why control of humidity is being utilized through cooling tower principles. The second one is the cooling and recovery of water in process industries. This reflects the environmental considerations being one of the preference in employing evaporative cooling, because through contacting with low humidity air, the water can be recovered and still be used to subsequent processes. This water recovery system is commonly employed in hydraulic power plants. Another application of evaporative cooling principles is through gas scrubbers. Scrubbers are often applied to removing dust from a gas stream or for reacting the liquid with a component to the gas stream, as well as for the removal of a condensable component from the gas phase. When it comes to solvent recovery system, the humidification is being used as part of it, but in these applications, the condensable vapor is not water but instead a solvent such as trichloroethylene, benzene, and methanol. As for the objectives of the discussion, the first one is to be able to know the significance of cooling towers in the process industries. Second, to be able to understand the principle behind evaporative cooling process using cooling towers. The third objective is to be able to know the difference between mechanical draft cooling towers and natural draft cooling towers. Fourth objective is to be able to know the applications of cooling towers in process industries. And the last one is to determine and evaluate cooling tower characteristics.